Hi friend, today I discuss a topic from ordinary differential equation, mainly homogeneous linear system with constant coefficient. So first, consider a system of equation. Consider a system of linear equation dx1 dt equal to a11 x1, right, plus a12 x2 plus a1n xn plus f1t. Here a1, a12, a1n all are function of t, right, and f1 is also the function of t. Now dx2 dt equal to a21t x1, a22 x2 plus dot a2n xn plus f2t. Similarly, dxn dt equal to an1 x1 an2 x2 plus ann xn plus fnt. Now this system of linear equation can be written as matrix form t of ddt of x1 x2 xn equal to here a11 a1n an1 ann and this x1 x2 xn, and here f1. These are function of t, also these are function of t. So in general it can be written as dx dt equal to, which is x is this column vector and a is this matrix and this is x, and suppose we denoted this by ft, right. So x is this and a is this n cross n matrix and ft is this column matrix, right. Now this equation is called homogeneous. This matrix form of this equation is called homogeneous if ft equal to 0. So a homogeneous linear system with constant coefficient is of the form dx dt equal to ax, right. Now non-homogeneous, when this differential equation is called non-homogeneous if ft not equal to 0. So this type of form. So a non-homogeneous differential equation system of equation can be written this of the form where ft not equal to 0, and if ft equal to 0 then dx dt equal to ax, where x is this n cross n matrix and a is the x is this column matrix and n row 1 column, and a is n cross n matrix, right. So here we study only the homogeneous linear system of equation. This first case we study. Now how to solve this type of solution? Suppose given there's an autonomous system dx dx1 dt, for simplicity take dx dt equal to a11 x plus a12y dy dt equal to d21x d22y. This is a autonomous system, right? So which is a here, a11, a12, a21, a22. You can also take a 3 cross 3 matrix. Basically we here discuss a autonomous system with and how to calculate the solution of this system. This system, suppose let a equal to this and x equal to xy, right? So this is a and this is x, so this can be written as dx dt equal to ax, right? So this is a homogeneous linear system of equation. And how to solve this system? Eigenvalue and eigenvector method. This is a 2 cross 2 matrix. Also one can get 3 cross 3 matrix. For simplicity we take this, and 2 cross 3 matrix, find the eigenvalue of a matrix. Suppose lambda 1 and lambda 2 be two distinct eigenvalue, right? Then which is the general, and suppose v1 and v2 with the eigenvalue eigenvector with respect to the eigenvalue lambda 1, and v2 with the eigenvector with respect to the eigenvalue lambda 2, the eigenvector, right? Then what is the solution? The solution x can be written as c1 v1 e to the power lambda 1 t plus c2 v2 e to the power lambda n t. This is the general solution, right? What is x? X is xy, and v also, suppose x1 x2. Then here we compare both sides, we get the particular x and y, right? We calculate here, suppose this is xy and c1, suppose v1 we get x1 x2 to the power lambda 1 t, and you get v2 x3 x4, then e to the power lambda 2 t, right? And here you get e to the power lambda 2 t. So compare what is x, c1 x1 e to the power lambda 1 t, right? And c2 x3 e to the power lambda 2 t, and y is similarly we get this c1 x1 to the power x2 e to the power lambda 1 t plus c2 x4 e to the power lambda 2 t. So these are the solution, general solution. Now if A is a n cross n matrix, then what is x? X can be written as c1 v1 e to the power lambda 1 t, and here the n cross n matrix and n eigenvalue all are distinct, we let. So cn vn and the lambda n be the eigenvalue and vn be the corresponding eigenvector, then lambda n t. This is the general solution for n cross n matrix. Now this is case 1. For lambda 1 lambda 2 is unequal. Now if next, suppose lambda 1 equal to lambda 2, these are equal, right? And suppose v1 with the eigenvector corresponding to the eigenvalue lambda 1, then one can calculate how to calculate v2. this is a shortcut method for calculate v2 a minus lambda I, lambda 1 I, lambda 1 lambda 2 is equal, so you can lambda 1 or lambda 2, v2 equal to v1. This is the formula for if lambda 1 equal to lambda 2, then v1 be the lambda eigenvector corresponding to the eigenvalue lambda 1. Then how to calculate v2? Use this formula and calculate v2. Then what is the general solution? For this case, this is case 2. General solution, what is the general solution? General solution is x equal to, here write c1 v1 e to the power lambda 1 t, and here c2 v1 t plus v2, right, e to the power lambda 2 t. This is the general solution. Now in the case 3, if the eigenvalue lambda 1 and lambda 2 are complex, means lambda 1 suppose alpha plus I beta, this type of solution, then we know that if lambda 1 is the form alpha plus I beta, then lambda 2 must be of the form alpha minus I beta, because the eigenvalue are conjugate to occurs conjugate type complex eigenvalue, right? We know this. Now if lambda 1 be an eigenvalue and suppose v1 be the eigenvector, right, corresponding to the eigenvalue lambda 1, then here we cannot calculate the eigenvector corresponding to the eigenvalue v1, right? There is a shortcut method to find the general solution. We write first this. Suppose v1 equal to half v1 equal to v1 bar. v1 bar means if suppose v1 equal to alpha plus I beta, alpha 1 beta 1 and alpha 2 plus I beta 2, then what is v1 can be written this of the form alpha 1 alpha 2 plus I beta 1 beta 2, then v1 bar means here this is negative sign. So if lambda 1 and lambda 2 both are complex and take v1 be the eigenvalue corresponding to the eigenvector lambda 1, v1 be the eigenvector corresponding to the eigenvalue lambda 1, and suppose b1 equal to this and b2 equal to half of, sorry, here I by 2 minus v1 plus v1 bar, this is b2. Then the general solution, now here suppose then x1 equal to, what is x1? x1 equal to b1 cos beta t minus b2 sin beta t. Why is beta? Beta is the imaginary part of the eigenvalue into e to the power alpha t, right? And x2 equal to beta 1, sorry, beta b2, this is not beta, b2 cos beta t plus b1 sin beta t into e to the power alpha t. We consider these two type, then the general solution c1 x1 equal to c2 x2. Right, this is the general solution. This is a shortcut method. One can also find lambda 2 corresponding to the eigenvalue v2, then apply the previous method. But here not calculate the v2 because this is a formula that if v1 equal to this and v2 equal to this, then x1 consider a function x1, this is this, and x2 equal to this, then this is the general solution. But c1 c2 with the arbitrary constant. So in next class I consider some problem about this. So thank you for watching. Thank you.